Number 9. No? Anyone for number 9? Number 10? We're okay? Number 11? Yeah. Number 11, use the triangle on the right to write down the values of sine squared 60. Okay, so look. This is root 3. This is 1. This is 2. This is 30 degrees. This is your right angle, and this is 60. Okay, this is your hypotenuse. The opposite and adjacent could be, it depends on which angle you're talking about. Okay, but the hypotenuse never moves. So then they asked me for sine squared 60 plus cos squared 30. Okay, sine squared 60, girls, is another way, and please note this, right? Okay, sine squared 60 is how they write sine of 60 all to be squared. It's how they write sine of 60 all to be squared. And cos squared 30 is how they write cos of 30 all to be squared. Is that okay? That's just how they write it. Okay? So sine of 60, 60 is here. So this is the opposite, this is the adjacent. So sine is SOHCAHTOA, sine is opposite over hypotenuse. So opposite is root 3 over hypotenuse is 2, right? That's sine of 60 and you want to square it. Okay? Cos of 30, now when you're talking about 30, this is the opposite and this is the adjacent, right? So opposite and adjacent move around depending on what angle you're talking about. So cos is adjacent over hypotenuse. So the adjacent is root 3 and the hypotenuse is 2, and you want to square that answer. So into the calculator, press equals, and you'll end up with 3 over 4 plus 3 over 4, which would be 6 over 4, which would be 3 over 2 on the calculator. Is that okay? Are we good with that?
Miss, if you switch around the opposite and the adjacent, do you get it wrong? I did 30 over 2. Oh, never mind.
You're okay?
Yeah. I did the angle, never mind, sorry.
Right.
Yeah,
You're okay?
Yeah, sorry.
Right. Okay. Girls, even writing down SOHCAHTOA and marking the hypotenuse will get you marks. Just so you know, they throw marks at you at maths for the smallest step in the right direction will get you marks. So if you read a question and you haven't a clue where to go, throw something down. Pick out 2 numbers and multiply them. Chance your arm, right? Yes. Question.
Why are sin and cos squared?
Because that's what the question asked me to do. It's in the question. Okay, so it's sine squared 60. That's how they write sine. Get the sine of 60 and square your answer. That's how they write it. Okay, so please note, that's how they write. Get the sine of 60 and then square your answer. Okay, right? Are we good with that? Right, 12. Yes, no, maybe? Yeah? Okay. Can I go? Right, so 12 has a right angle triangle here, and then we have another triangle up here. Okay, we have 9 centimeters, we have 12 centimeters, we have a right angle, we have 63 degrees, we have 14 centimeters, and in part 1 they asked me to get the length of B to D, which is, I'm going to call that X, and in part 2 they asked me to get the area of the whole shape. Right, okay, are we good with this? Right, there's 2 triangles here. There's a triangle here which is right angled, there's a triangle over here which is non-right angled, so we're using SOHCAHTOA, and then we're using the sine rule and the cosine rule for that triangle. Which triangle do I start in and why? You start in the right angle triangle. Why? Because in order to work in a triangle, you need 3 pieces of information. So I have 3 pieces of information here. I know that's 90 degrees, I know that's 12 centimeters, and I know that's 9 centimeters. So I have 3 pieces of information in that triangle. I do not, in the other triangle, I have only 2 pieces of information. But if I work, yes?
Is that the second triangle and the triangle?
This one, no, it's not. Right? Because if it was an equilateral triangle, all angles would be 60. So it's not, and it's not isosceles either because they haven't told us. Right? So you can't make an assumption. Sorry. Okay. Right?
Is it only an isosceles that has a few lines in it?
Yeah. If it was isosceles, they'd put a line there and a line there. But they haven't. So it might turn out to be, but I don't think it will be, to be honest. Right? Is that okay? So, are we good? So, we have to work in the right angle triangle to start with. Okay. Now, in the right angle triangle, I can use SOHCAHTOA or I can use Pythagoras' theorem. I need to find this line. How do I find it? When I have 2 sides and I'm looking for the third side of a right angle triangle, I use what? Pythagoras' theorem, don't I? The square and the hypotenuse, and this is the hypotenuse equal to the sum of the squares of the other 2 sides, yeah? So x squared, well, I'll just call it h squared. H squared is equal to 12 squared plus 9 squared. Are you all with me? Right, so into the calculator of that, h squared, that's 149 plus, or 144 plus 81, which is 225. And then get the square root of 225, which is 15.
Miss, I used the cosine rule, is that okay?
Use the cosine rule, and you still got 15.
Yeah.
Yeah, that's grand. It's a lot of work though, just to avoid Pythagoras' theorem.
Yeah.
Right, okay, but it's still correct. You can use the sine rule and the cosine rule in right angle triangles. It's just easier to do it the other way. Right? It's a lot of work, but you got there. So you get the full marks. Is that right?
Yeah.
Okay. So 15. Are we all happy with that? Okay, so I'm going to go to the other triangle now. So I know this is 15. I know this is 63. And I know this is 14. Right? They want me to get the area of the whole shape. So I need to get the area of each triangle and add my answers, right? Because the whole shape is a weird looking shape. I don't do weird looking shapes, I do triangles, right? Okay, is that right? So this is 12 centimeters, this is 9 centimeters, and I just figured out this one is 15 centimeters. I may need it, I may not. Okay, right. This is a non-right angle triangle, so the only way I have of getting an area of a non-right angle triangle is to use the formula half AB sine C, yeah? So this is the angle I know, so I'm going to call that C, small c. And then it doesn't matter, capital A, capital B, small b. Okay? So it's a half multiplied by small a is 14. Multiplied by small b is 15, multiplied by sine of angle C, which is sine of 63. Into the calculator with that and press equals, right? So if you're in the trig question and you're asked for area, girls, this is the only area formula we have. Okay? Right. Will someone give me an answer for that? Find correct to the nearest whole number, so you can just give me correct to the nearest whole number. Actually, give me a couple of give me one decimal place and then I'll round in the end. So 7 15s. 93.556. Lovely. That's the area of that triangle. I wanted the area of the whole shape, so I also have to get this triangle. Right? Girls, I have no angle here, so I could use that, couldn't I? Do you want to use that? Or do you just want to go half the base by the perpendicular height? I can use that for right angle triangles, can't I? Half the base by the height. So that's a half multiplied by 9 and the perpendicular height is the straight up height, which is 12, and when you into the calculator that, press equal to get 54, I think. Right? Okay. Then you add your two answers to get the area of the shape. So I have 147.556, and they said correct to the nearest whole number, that would be 148 centimeters squared, because it's area. Okay? We good? Remember, this is the only way we have of getting area. That's the only way we have of getting area, right, in the trig question. Okay? Right. Are we good? Right, 13. Am I doing it? Anyone? No? Okay. 14. 14. Anyone? 15. 16. Which one? 16. Right, okay. 16 looks very interesting. A large metal frame window has a semicircular top on a rectangular frame as shown. Using the two measurements given, give your answer to the nearest centimetre, the length of DC. Right, so look, I'm just going to draw out the whole lot. Okay, they told me that's a rectangle, so I have right angles in there. Okay, so that's 48. This would be 72. And that's all they give me. Okay, so I need to find the length of D to C. So D to C is this line here. D to C, they surely have told me more, have they? Because I don't have three pieces of information. This is on a rectangular frame as shown. These are two measurements given to find you that. Wait now till I see. I've only, oh no, right, yeah, I'm okay. Look here. Big right angle triangle, look where I'm going, look at it. You see it? So this is 48. This is 72. And this is X down at the bottom, and they told me that's a rectangle, so I know that's a right angle. With me? Does everyone see where I got that? Wait, I get a colour D pen. Right, okay, this is this triangle there. Okay, and I have three pieces of information in that triangle, don't I? Right, I have right angle, 48, 72. In fact, I could actually get the third angle in it if I wanted to. How would I get the third angle in it? Three angles in a triangle add to 180. So I have 90 and 48, that's 138, take away from 180. That's actually 42. Okay? Right, whether I need it now or not, I don't know. Right? Are we good? Right. I need to find the X. So I'll talk about this angle because this is the one they gave me. So I'll pretend I don't know this a minute. This is the hypotenuse. This is the opposite. This is the adjacent. Okay, I'm looking to calculate the opposite. So SOHCAHTOA. So when I know the angle, I can get the sine, cos and tan of the angle. So I know sine, cos and tan because I know the angle. I know the adjacent, the adjacent, the adjacent. I'm looking for the opposite. So I want to know what the opposite is. Right. I have no interest in the hypotenuse. They didn't ask me, I'm not going to tell them. Right, okay, is that alright? So I'm going to use 10, agreed? So 10 is over A, so that means 10 of 48 equals, opposite is X over 72, and when the letter's on top, just cross multiply. So 1 by X is X. Across this way I go 72 multiply by 10, 48 into the calculator, press equals. Someone might give me an answer for that. Give your answer correct to the nearest whole number, they say.
80.
Tell me again.
80.
80, 80,
Yeah.
right, okay, so 80. So that line there, down at the bottom is 80 centimetres. Okay, right, so we're building up the information for the next parts of the question. That's part one. Right, okay, part two. They asked me to find the length from A to C. So from A to C, girls, is here. Okay, isn't it? So it's in the opposite right angle triangle there at the other side. Okay. And it's the diagonal. So I'll call this X this time. Is that okay? Now I know this line is 80 centimetres. I've just calculated it. I also know this side is 72 centimetres. How do I know that? Because they told me it was a rectangle. So if this is 72, this is 72. With me? Right, okay. Right angle triangle. I know two sides. I'm looking for the third. What do I use? I'll answer my own question. So, Pythagoras' theorem. So this is the hypotenuse. So the hypotenuse squared is equal to the sum of the other two sides squared. So 72 squared plus 80 squared into the calculator with that, and you'll get h squared is equal to, yeah, someone might do it, or if anyone has the answer already.
11,584.
584, and then get to square root of your answer, and it is correct to the nearest whole number. They go again.
108.
What's it?
108.
108. Okay, grand. Okay, 108. Is that okay? Are you all with me? So I'm just going to write in that diagonal there. It's 108. The other diagonal is also 108, but it would be, yeah. Okay, right. Where am I going now? The arc length of AB, right? The arc length of AB. So look, I need the length from here to here. Agreed? That's a semicircle. Agreed? It's the length of a semicircle. So the length of a whole circle is 2 pi r. I only have a semicircle, so I'm going to divide by 2. So I need the radius, right? So I need the radius of this, right? So a radius is from the center of the circle out to the edge, yeah? Would you agree? That's radius from the center of the circle out to the edge. So from the center of the circle out to the edge. From the center of a circle out to the edge. From the center out to the edge. From the center out to the edge. Yeah? Okay? Right. We know the whole length of that line though, there, don't we? We just figured it out there a minute ago. It's 80 centimetres. So what would the radius be? 40. Wouldn't it be half that? Because there's 2 radii there. So if the whole lot is 80, the radius is 40. Right? So for that, that's 2 multiplied by the pi button on your calculator, multiplied by 40, divided by 2, because we only have a semicircle, we don't have the full circle. Is that okay? Into the calculator with that, press equals, press S to D, and round it up to the nearest whole number, because that's what they told me. $132, I don't know.
Yeah, 126.
126. Right, thank you. Centimeters. Okay, because it's the length of an arc. You all with me? Finally, the last bit, part IV. So this is part 3. Part 4. The total length of metal needed to build this frame. Okay, right. We have it all done already, so it's just a case of adding a few numbers. So every bar, right, we've actually got the measurements for. We just need to add up all the bars that they have. Okay, and I'm missing one. There's a one there as well. There's one up here as well. Okay, right. So will we start with the semicircle, right? Yeah, because we just did that. So we have the semicircles. So 1, 2, 6 plus 1, 2, 3, 3 radii. Would you agree? 40 plus 40 plus 40. Right. We have across here, which is 80. And we have the bottom one as well, which is also 80. And then we have the side one, which is 72. And we have the other side, which is 72. And then I have the two diagonals, which I found out to be 108 and 108. Okay, so I've all the work done. I just had to add up all the measurements. Is that all right? Okay, into the calculator with that, press equals 24, 280, 406. Thanks. 736? 766, sorry. 766. And they're all in centimeters. Is that all right? So really not that bad when you break it down. When you look at it first, it's like, oh my God. But really not that bad. Like in there, you did a SOHCAHTOA, you did a Pythagoras' theorem, you got the circumference of a circle, and you added a few numbers, right? When you break it down, it wasn't that bad, sure it wasn't. But looking at it first, it would actually scare you, right? It scared me when I looked at it first. Right, okay, are we good? Right, okay. I gave you the area and volume sheet for the weekend, time-wise, 11:33. I have 12 minutes. Will I start geometry? Will I not? You're shaking your heads. Do you want to start that sheet? So I'll start geometry on Monday. There, the sheet I just gave out. Is that the one I just? No. Sorry? No, I put that one up yesterday. Didn't I? Did I? But I said I'd print you out a hard copy today if you wanted a hard copy. So, yeah, you can do it online if you prefer, if you don't want to be touching stuff. But, yeah, that's the only sheet I gave out. Okay. So I'm going to mark that as a test, okay? But you can use books and your notes and whatever else you need. I'd appreciate though if you didn't get someone else to do it for you, because that's not really, we don't need to fool anyone, we just need to. Girls, I was looking at the pre is also quite hard, okay? So can I tell you now, expect to not do well in it, okay? But look, put it in context. We haven't done any exam papers, right? We've done no revision, so you're going to be looking at some questions that you haven't done since the start of 5th year, right? Okay? And I'm not going to have any revision done before the pre because I'm finishing the course. So the pre is going to be a disaster. Do you all hear me now? It's going to be a disaster. That's okay. Right, that's fine, that's expected, it always is, right, okay, but I'm just tipping you off right now, it's going to be a disaster, right, okay, and expect it to be a disaster, and then you get better, right, and you make it better by doing, yeah, is that okay? So expect it to be awful, because it is.